This is Mount St. Helens. And this is a very special type of zone. This is what's called a subduction zone. A subduction zone occurs on the Earth where you have a plate, and in this case it's the ocean plate. Now the ocean plates are denser rock, and so they're heavier, so they sit lower than the continental plates. And what happens is it ran into the continent here and pushed it up. So this is my continental plate right here, and it pushes it up, and you get volcanoes. So down here is magma, hot rock, okay? The mantle essentially of the Earth. This is the crust, this is the crustal plate or continental plate. But this is running into this. They're being forced together. And when they're being forced together, the ocean plate is pushed underneath the continental plate. Well, when it gets down here to the mountain, this is very hot down here. Remember, it gets hotter as you go. All this rock melts. And so once it melts, it gets lower density, and it starts working its way up, and it starts pushing its way up through the continental plate. When it does that, it pushes up these volcanoes. So this is a volcano. This is called a composite volcano. And this is occurring on the northwest coast of the United States. The Pacific plate is being pushed down underneath the continental plate because the Atlantic's getting bigger, the Pacific's getting smaller. In fact, this is occurring pretty much all the way around the Pacific. And that material comes up and pushes up these volcanoes. This is Mount St. Helens. Mount St. Helens, back in about 1979, looked more like this. But then it erupted, and it blew the whole top of the mountain out. Why would it erupt? Well, once this hot magma material gets up here, it hits the water from all the snow and ice and turns it into steam, superheated steam, thousands of degrees, and eventually that creates a massive amount of pressure, and that pressure blows the whole top of this off. Now, when this occurred, I was living in Montana. I grew up in Montana. And if you remember, here's the United States here. Here's the United States, kind of west coast, Mexico. You get the idea here. I was living here. This is Montana. I was living right here. This occurred over here in Washington State, the bottom of Washington State. Well, it blew so much ash up into the sky that it created a cloud of ash that fell all the way across Montana, even into North Dakota, parts of Canada. One day, Monday, we came out, and this happened over the weekend, and there was about that much ash, about an inch and a half of ash covering everything. It was the weirdest thing ever. Everything was gray. You felt like you were on the surface of the moon. The cars were gray, the tree was gray, the lawns were gray, everything was perfectly gray. They actually canceled school that day because they didn't want anybody walking out there. They didn't want the kids going out there breathing this stuff because it has lots of tiny particles of glass and stuff, and so it's not good for you. And it was kind of weird because in Montana, we never closed school. This idea of closing school for a snow day, we'd close like all the days. If you lived in Montana, you would only have about half the days if you closed for school. So they never close school unless you get volcanic ash on you. Then they close the school. All right, but that was way back in 1980s. This is it growing up again. And you can see it blew off the whole top of the mountain, but then there's a new cone forming. And this is steam coming out. So it's still active. It's just going to take a while to build up, and then it'll do the same thing again. All right. This is another subduction zone, because in a subduction zone, so here's the ocean right here. Notice that where it pushes it down, you get a gap, a deeper hole. This is called a trench. That's where the deepest parts in the ocean are. This is what's called Marianas Trench. Marianas Trench. These are the Marianas Islands, and right outside here, the Pacific plate is being pushed below this plate, this continental plate. Even though there's water on it, it's still a continental plate. It gets pushed below it, and it makes a trench. That's the deepest spot in the oceans on the whole Earth. And parts of it goes almost 7 miles straight down. And people explore it, but you have to have very, very specific submarines that can handle that kind of pressure. Most of them can't do it for very long. It's very dangerous that it'll implode on you. But that's part of a subduction zone as well. All right, the Philippine Islands are a subduction zone. Japan is a subduction zone. That's why from Tokyo, you can see Mount Fuji. I went to Tokyo, and from my hotel room, I could see Mount Fuji out in the distance. That is a volcano from a subduction zone. All right, but we can have other kinds of interactions between plates. We can have plates that slide next to each other. So we got one plate here, another plate next to it. So one's going this way, one's going this way. Or in this case, I'm going to switch them around. This plate's going this way, this one's going this way. Where they interact is what's called a transverse fault. Okay, so you think of it as here's a plate, and they're sliding next to each other. But they don't slide nice because all the rocks and stuff grab. And so they catch and they get locked, and then the pressure keeps building, and then they snap. And the whole plate will jump a certain distance. The perfect example of this is the San Andreas Fault. In California. This is the one that goes right through Los Angeles, all right up through San Francisco. This is it. You can see it right here. Notice, you got to look at this closely, but you see this? This is a river. But then the river goes over here. So when the river was flowing originally, it would go straight across. But this part, the top part here, has moved this way, and this has moved this way, and so now it has to go all the way down like this to catch up to where it matched up before. And you can actually measure how much that land is shifting. This is the one that caused the great earthquake in 1908 in San Francisco that burned down San Francisco. Because what happened is gas mains broke, and then the fire started, and there was no water because all the water mains were broken, so they couldn't put it out, and pretty much most of the city burned, and they had to rebuild completely from that point. This fault also goes all the way through Los Angeles, then it comes back out into the ocean again, and eventually they're going to have earthquake. This is not one of these that, oh, they might have one. No, they're guaranteed they're going to have an earthquake. It's just nobody's sure when. Okay? They seem to have, looking at the geological record, every 100 years or so you have a major earthquake on this fault. Shifts, jumps, and then it releases the pressure, and then it takes another 100 years for it to build up again before it jumps again. This is not a subduction zone. This is what's called a transverse fault, when they're sliding next to each other like that. All right, we also have what's called a rift zone. A rift zone occurs whenever you have a plate and another plate, and they're pulling apart. When they separate, then the magma from below, remember this is the liquid rock, will flow up in between, and then it cools off and solidifies, and you create new land in between. Okay? This is happening all down the middle of the Atlantic Ocean as the ocean pulls apart. And the interesting thing is you can date rocks on this side and this side, and they match. And then you go further out, these are older, they match as you go out. That's one way they can tell that the Atlantic is split apart, where North America and Europe were once next to each other and they split. They can match up the ages of the rocks, and they get older as you go outward from the center of the Atlantic ridge. Now this, occasionally, you can get enough magma pushing up that it pushes up above the ocean, and you create islands. That's what Iceland is. Iceland sits exactly on top of the mid-Atlantic ridge, which means it's very geothermally active because there's all this hot magma coming up, and it's still splitting apart. This is the rift zone on the island of Iceland. You see, it's actually just cracking. The land is splitting apart, and it will continue to do that. They have very active volcanoes right here. These are usually not the explosive type volcanoes, but they do spew out all kinds of ash and lava, and this occurs regularly. I think it was 4 or 5 years ago, volcano in Iceland erupted, it spewed ash all over Europe, and they had to shut down all airplane travel anywhere over Europe, even into Eastern Asia, because of the ash. the ash destroys jet engines if you try to fly through it. So it's very, very bad for airplanes, so you have to just shut down and avoid that area. All right, this is Hawaii. Like, why are we talking about Hawaii? It's in the middle of the Pacific Plate. Well, it is, but here's the ocean. So here is North America, South America's down here. Got the idea. Over here is Asia and Japan, and Australia, and New Zealand. And Hawaii is about here. Yeah. However, Hawaii is not a single island. It's a whole string of islands. It's a string of islands that go up like this. Yeah. Now, there's no continental plate right there. Remember, the continental plate boundary or the ocean plate boundary is all along the edge here. And so that's why there's volcanoes all around the edge of, volcanoes and earthquakes all around the edge. They call it the Ring of Fire around the Pacific. But right in the middle of the Pacific is what we have, is what's called a hot spot. And a hot spot is where we have a crust. Here's the crust going over it. And then there's a spot where the mantle is pushing up through the crust. Essentially, it's like having a flame there, and it's burning a hole. And then the whole plate is moving, so it keeps burning a hole in the same place, but the plate keeps moving, and so you keep moving it to a new place. This is the big island of Hawaii. Hawaii has a whole bunch of islands. But you see here, essentially Hawaii is made of these volcanoes. There's two volcanoes, two major volcanoes. This is Mauna Kea, this is where the observatories are. This is Mauna Loa, which is where the active one